Hello everyone and welcome. In this video, we are going to explore circular linked lists. These are special types of linked lists that form a loop, connecting the last element back to the first. Get ready to dive into the details of how these lists work and where they can be useful. So, what exactly is a circular linked list? It's a type of linked list where the last node doesn't point to null, but instead points back to the very first node in the list. This creates a closed loop or a circle of nodes. Because of this circular nature, circular linked lists have some unique characteristics. First, there are no null pointers, as the list forms a complete loop. Second, you can start traversing the list from any node. Any point can be the starting point. Third, because there's no null to stop you, traversal needs a different kind of stopping condition. Lastly, circular linked lists are very efficient for applications that need cyclic access, where you repeatedly go through the elements. Let's take a look at how a circular linked list is structured in code. We typically define a node with two parts: data, which holds the value we want to store, and next, which is a pointer to the next node in the list. The last node's next pointer points back to the first node, creating the circle. We also have a head pointer that points to the first node of the list. In this example, you can see the structure of a node containing a data field and a next field. The data field stores the value 42, and the next field contains the address of the next node. Below that, we see a simple linked list where the head points to the first node with the data 10, then the next node with the data 20, and finally the third node with the data 30. The final node points back to the first node, closing the circle. Now let's walk through the process of creating a circular linked list. First, we dynamically allocate memory for each individual node using the malloc function. Then we assign the data values to each of these nodes. After that, we connect each node sequentially using the next pointers. Finally, to make the list circular, we connect the next pointer of the last node back to the first node. Here's an example where we create three nodes, assigning 10, 20, and 30 as their data respectively, and create a circular list with the head pointing to the node containing 10. Traversing a circular linked list requires a slightly different approach compared to a regular linked list, mainly because there's no null to signal the end. Here's the code to traverse a circular linked list. First, handle the empty list case by checking if the head is null. If the list is empty, we print a message in return. Now, we create a current pointer which initially points to the head. Then we use a do-while loop to process each node. Inside the loop, we print the data of the current node and move the current pointer to the next node. This loop continues until the current pointer returns to the head again, signifying that we have completed a full circle. Remember, a key concept to keep in mind is to use a do-while loop instead of the while loop to process the first node. Inserting nodes in a circular linked list involves a few different scenarios, each requiring slightly different steps. We can insert a node at the beginning, at the end, or in the middle of the list. When inserting at the beginning, we need to update the last node to point to the new node and then make the new node point to the original head. Inserting at the end involves finding the last node, making it point to the new node, and then making the new node point back to the head. Inserting in the middle is similar to a regular linked list, but you need to ensure that the circular structure is maintained. In this example, we want to insert a new node with the value 5 at the beginning of the circular linked list. In order to do this, we need to make sure the new node with value 5 points to the head and the last node points to the new node. Let's explore some real-world applications and key advantages of circular linked lists. Circular linked lists can be used in operating systems for something called round-robin scheduling, where each process gets a fixed time slice in a cyclic manner. They are also used in implementing efficient first and first-out buffers. Also, in multiplayer games, they can be used for managing turns where players take turns in a cyclic order. Compared to linear linked lists, circular linked lists don't have null pointers, offer constant time access to both ends, and are efficient for cyclic operations. Some key advantages of circular linked lists are that they can traverse the entire list starting from any node without needing to track the head separately, They are ideal for applications requiring continuous looping through elements without stopping, and offer efficient memory usage because they don't need to store null pointers. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.